Tesla has been making impressive progress in the development of the Optimus humanoid robot. According to Elon Musk, there are already concrete plans to put more than 1,000, or even a few thousand, of these robots into operation within the company's own facilities soon. According to him, Optimus can already move around on its own in about 95% of complex environments and respond to stimuli in just 20 milliseconds. With this, the company is preparing to begin large-scale production. The goal is to manufacture 10,000 units of the third-generation Optimus by 2025. To make this ambitious plan possible, Tesla is using its entire artificial intelligence ecosystem, its already consolidated production capacity, and a broad base of practical tests with more than 1,000 real-world tasks. And in this episode, we will explore official data, technical demonstrations, and concrete evidence to find out if this project is really ready to get off the ground. Then, we will analyze pricing and, finally, show the full launch schedule. But first of all, it is essential to understand what exactly the Tesla Bot Gen 3 promises to deliver, and whether or not it is worth the investment. Now, imagine the following scenario. John Kennedy, a man over 70 years old, falls at home. He feels intense pain in his back and hips and is unable to move. His cell phone is nearby, but out of reach. He is alone. At that moment, a humanoid robot detects what has happened, carefully approaches, gently lifts him, assesses his condition, and sends a direct alert to the attending physician. The doctor's recommendation? Hospitalization. But John refuses. He doesn't want to spend the rest of his life in an institution, waiting for the days to pass. What if there was an alternative? The Optimus Gen 3 was created with this mission in mind, to provide support without taking away autonomy. It can make drinks, organize the house, fold clothes, and even sense when the best thing to do is just sit quietly next to you. It can accompany someone on a walk or prepare a simple meal in less than 30 minutes. This way, John could continue to live independently, comfortably, and safely in his own home. This is the future that Tesla is building, and it is closer than many imagine. As promised, we will detail the production plan and official schedule for Optimus Gen 3 shortly. But first, it is important to understand how Tesla is preparing this robot to face everyday challenges. After all, is it really useful? What tasks has it already mastered? Optimus Gen 3's design is based on a neural architecture inspired by Tesla's self-driving system. This allows the robot to interact with its surroundings in real time. According to researcher Milan Kovic, Optimus' internal controls operate with extremely low latency, between 2 and 3 milliseconds, updating its state up to 500 times per second. Instead of just reacting, it can predict movements, a capability Musk calls future vision. When descending a staircase, for example, the robot not only adjusts its steps, but also anticipates the movements and balance needed for the next 3 steps. This drastically reduces the risk of falling. This anticipation is reinforced by a system of multimodal sensors. The robot's head has a set of cameras with 360-degree vision, similar to Tesla vehicles, while its hands have tactile sensors so sensitive that they can hold a raw egg without breaking it, or even nimbly catch a tennis ball in midair. During recent tests, a curious detail caught our attention. The Optimus Gen 3 managed to fry an egg with precision. It adapted the force applied by the hands when holding a cold cardboard box and then a hot frying pan, all in real time. The mechanical improvements in this new generation represent a technological leap forward compared to previous models. The hands, for example, now have 22 degrees of freedom, twice as many as the previous generation, and are now capable of performing 47 of the 50 tasks with human-like precision. The artificial motors and tendons provide movement accuracy of up to 0.1 millimeters. In a viral video, the robot is seen threading a needle all by itself, something that opens the door to very sophisticated industrial applications. This impressive dexterity allows the Tesla bot to perform high-precision tasks, such as assembling electronic components in factories. In the home, it can handle delicate objects with great care, such as folding laundry or arranging flowers, with astonishing precision. Advances in mobility are also notable. The latest models are capable of tackling ramps of up to 45 degrees and descending stairs fluidly, something that previous models could not do efficiently. This was only possible thanks to actuators inspired by human biomechanics, especially in the ankle region, which adjust the stiffness of the joints in milliseconds, even before the foot touches the ground. And we're not just talking about theory. Tesla has released videos on its official X account, formerly Twitter, showing Optimus moving on steep terrain and uneven vegetation. Elon Musk has said that the robot is able to walk on unstable surfaces thanks to neural networks that control each limb independently, without any kind of remote control. Milan Kovac, vice president of engineering for the Optimus project, highlighted an interesting detail. The robot can maintain balance even without using its vision. In one test, Kovac slipped in the same place where Optimus walked firmly, which shows the level of sophistication of the locomotion system. Now, the big question, how much does a humanoid robot like this cost? During the CES technology trade show, the hallways were lit up with thousands of LED screens and displays of cutting-edge robots. Among the visitors were Jenny and David, a couple who walked slowly, observing each innovation with attentive and curious eyes. When they watched a promotional video for an agile, interactive humanoid robot, they were completely enchanted. It wasn't just a home assistant. The robot could talk, remind people to take their medication, and provide companionship for the elderly, easing the emotional burden many families face. Jenny immediately imagined the machine organizing the house, helping David with chores, and caring for her hyperactive grandson. The future seemed closer and full of possibilities. "How much does it cost?" David asked, a little hesitantly. With a welcoming smile, the attendant replied, "The basic version costs $140,000, but we have financing and installment options." David let out a sigh and looked at Jenny. "So, can we do it?" That's exactly why Elon Musk's proposal to launch the Tesla Optimus for less than $20,000 is causing such a stir in the robotics industry. The idea goes beyond simply lowering the final price. The intention is to transform the market based on three main pillars. Reducing battery costs. Tesla's large-scale production of 4,680 cells has significantly reduced the cost of this key component. Standardization of parts. Approximately 78% of Optimus components are the same as those used in Tesla vehicles, optimizing the entire production and research chain. Monetization via software. The company plans to offer premium features through monthly subscriptions, including AI-powered personal assistants, senior care protocols, and educational support. Initially, large corporations and healthcare networks are expected to be the first customers. But Tesla is already developing a version for homes, aimed at the average consumer, with functions aimed at child safety and even the ability to learn cooking recipes. According to a leaked memo from a major U.S. retailer, the Tesla Optimus Gen 3 is expected to launch in the fourth quarter of 2025 with a suggested retail price of $19,999, plus an optional AI services plan for $199 per month. In today's robotics landscape, Boston Dynamics Atlas is still seen as a masterpiece of engineering and is often cited in research centers as a milestone in technological advancement. However, its astronomical price tag, around $2 million, and its low commercial viability severely limit its use outside of laboratories. In contrast, the Tesla Optimus, especially in its third generation, emerges as an innovative and revolutionary alternative. Thanks to Tesla's fully integrated production model, each unit costs just 1% of the price of the Atlas, with the advantage of incorporating much more sophisticated artificial intelligence. While the Atlas relies heavily on pre-programmed routines, the Optimus learns new tasks by observing and applying reinforcement learning. A practical example of this was when the third generation of the robot taught itself how to operate an espresso machine, simply by watching a barista in action. Asian competitors, such as Unitree and Fourier Robotics, have already launched humanoid robots at more affordable prices, between $50,000 and $100,000, but they do not have the advanced AI infrastructure developed by Tesla. These solutions generally perform tasks based on fixed commands. Optimus, on the other hand, has the ability to adapt in real time to unexpected situations. In a live demonstration, for example, a prototype stopped its activity when it noticed a spilled liquid, fetched cleaning materials, and only then returned to work. All of this completely autonomously, without human intervention. With a price that is starting to seem more affordable and justified, an important question arises. Will the average consumer be able to buy an Optimus? Or will all production be destined for companies by 2025? Will it be possible for individuals to make reservations? The truth is that Tesla intends to manufacture 10,000 Optimus units by the end of 2025, a clear indication of the company's commitment to expanding humanoid robotics. Elon Musk acknowledges that the goal is ambitious, but points out that even delivering a few thousand would be a significant milestone. Initial production is scheduled to begin at Tesla's factory in Fremont, California, which is already gearing up to assemble the first 1,000 robots in the first quarter of 2025. From there, the plan is to gradually ramp up production until it reaches 10,000 units over the course of the year. This staggered strategy follows the same path that Tesla took in the early years of its electric cars, encountering initial bottlenecks, learning from them, and then rapidly accelerating. Tesla's confidence in this plan comes from its expertise in key areas such as batteries, motors, and artificial intelligence systems, all of which it has acquired through its autonomous vehicles. Many of the sensors and actuators used in Optimus come directly from technology used in Tesla cars, making the production process more efficient and cost-effective. Furthermore, Elon Musk has already confirmed that the assembly lines for the third generation of Optimus are being designed to reach a production of up to 100,000 units per month from 2026, showing that the company is betting big on global demand. Critics, however, remain skeptical that Tesla can meet this ambitious timeline, especially given the delays it has experienced on previous projects like the Roadster. But the context is different. Unlike the Roadster, which required an entirely new supply chain, the Optimus already has established partnerships for batteries and chips. And the restructuring of the Fremont plant to produce the Cybertruck has served as a test run for the rapid expansion of robotics production capacity. Recently, Elon Musk revealed that Tesla is already putting Optimus prototypes to work inside its own factories. These robots are being tested in simple logistics tasks, such as retrieving parts and monitoring parts of assembly lines. This practical testing environment gives Tesla a strategic advantage, mainly due to the huge amount of data that the company already accumulates. With more than 5 million vehicles on the road around the world, Tesla constantly collects real data that feeds and improves the artificial intelligence systems used in the robot. This exchange of knowledge between Tesla's automotive and robotics divisions creates a continuous learning cycle. For example, navigation algorithms originally developed for the car's self-driving system are being adapted to ensure Optimus can navigate efficiently in diverse environments. But Musk's vision goes far beyond 2025. He predicts that eventually Tesla could manufacture up to 100 million Optimus units per year, making robotics the company's largest source of revenue. While that number may seem exaggerated at first, the math makes sense. Given an estimated retail price of around $220,000 per robot, a viable figure of production reaches 1 million units per year, Tesla could generate around $20 billion from Optimus alone. Tesla has already identified 5 main areas for the use of the third-generation robot. In industry, it will be responsible for repetitive tasks, such as separating parts and performing quality inspections. In healthcare, it will help transport patients and deliver medicines. In retail, it will organize shelves, control inventory, and assist in automated sales processes. In the domestic environment, Optimus is being prepared to cook, clean, and even help with childcare. All of these functions are already in the final testing phase and should reach the market in 2025. Another application Musk is already planning involves using the robots to maintain future colonies on Mars, under the leadership of SpaceX. Rather than relying solely on human labor, engineers are adapting Optimus to withstand the extreme conditions of the Red Planet, with sealed joints and radiation-resistant electronics, with the goal of building space habitats autonomously. Initially, there were rumors that Optimus would be exclusively for internal use at Tesla factories, with no plans for the general public. But that has changed. Today, around 1,000 humanoid robots are already operating in the company's factories, performing tasks that not only speed up production, but also generate valuable data to further improve processes. This number is expected to grow very soon. Recent reports indicate that Musk is much more confident about the progress of the project, and it is estimated that the ratio of robots to humans in factories could reach 3, 4, or even 5 robots for each employee. On a global scale, this could mean somewhere between 20 and 30 billion units in the long term. Despite Tesla's reputation for delays on past projects, such as some electric vehicle models, development of the Optimus is moving forward at a surprising pace, faster than many experts had anticipated. The company is ramping up production of the first generation, perfecting the second, and is preparing to officially launch the third generation later this year. So far, Optimus has only shown a fraction of its true potential. In a recent presentation, the robot roamed a production line full of workers and machines, demonstrating its ability to navigate a dynamic and unfamiliar environment on its own. Just as a human might hesitate when entering a new location, the robot also assesses its surroundings before making decisions, but it does so entirely autonomously, interpreting machines, people, and the space around it to navigate. This ability makes Optimus a valuable asset to Tesla's production. And Musk isn't the only one betting on the future of humanoid robots. Investors around the world are pouring millions into robotic startups, seeing a market that could surpass $38 billion in the coming years. By 2035, new robotics companies are rapidly emerging in North America, China, and Europe, an unprecedented growth for the industry. But what really sets Tesla's Optimus apart is its ability to scale production. According to Musk, Tesla has developed every component of the robot in-house, from the actuators and robotic mechanisms to the electronics and batteries, all created by the company's own engineers. This vertical integration allows Tesla to quickly scale production without relying on outside suppliers. It is this autonomy that gives Musk the confidence that Optimus can be sold at a price well below the market average, with an estimated production cost of just $10,000 per unit. Tesla's progress with Optimus has been impressive, and if it continues at this pace, personal robots could become accessible to almost anyone, like having an R2-D2 or C-3PO in your home. With an estimated price of around $19,999, would you be willing to have a robot living with you, taking care of your family and even your children? And what do you think of Musk's prediction of manufacturing 100 million Tesla bots per year? Leave your opinion in the comments. Thanks for watching. If you want to keep up with more exciting news about Tesla, its electric cars, or the Tesla bot, don't forget to like, share, and subscribe to the channel.